Welcome back, everybody. We are going to finish up Chapter 8 today by talking about graphing quadratics in intercept form. Pause the video and jot this down on your vocab section. All right, remember, zeros and x-intercepts are the same thing. They just call them zeros because they are the solution and y is 0 when we look at the x-intercept. Let's take a look at what we have here. I'm going to start with labeling my P and my Q. And it doesn't matter which one is P or which one is Q. But remember that it's always opposite of whatever's inside here, because the original formula was x minus P and x minus Q. So we have x-intercepts. By doing this, we have x minus 1 is equal to 0. Because remember, on the x-axis here, our y value is 0. I'm going to add 1 to both sides. We get x is equal to 1, and that makes 1, 0, our x-intercept. X plus 3 is equal to 0. We subtract 3 from both sides. We get x is equal to negative 3. So negative 3, 0 is our x-intercept. So you can see why when we're looking inside these parentheses, things are opposite. We find the y-intercept the same way we did in the last section, where we plug in 0 for all x's and then evaluate or find the answer. So we have 0 minus 1 times 0 plus 3. 0 minus 1 is negative 1. 0 plus 3 is 3. Negative 1 times 3 is negative 3. So our y-intercept is at 0, negative 3. I'm going to pause here and put on our graph the values that we know. So we know 1, 0. We know negative 3, 0. I'm going to hold off on the y-intercept for a minute because we have to talk about finding the vertex. So we described in the vocab above, finding the vertex. The vertex has to be halfway in between our two x-intercepts. So I'm going to start with, what is the distance here between these two? So if I count the steps, 1, 2, 3, 4, then that distance is 4. So from negative 3 to 1, the distance is 4. We want half that distance, which is 2. That means the vertex is 2 steps from negative 3 and from 1. That's what that means. So I'm going to erase this and that and choose a different color here. I'm going to go with purple in there. So 2 steps from negative 3, 1, 2, puts me at negative 1. I know now that the x value of my vertex is at negative 1, and that also means that my axis of symmetry is at x equals negative 1. Again, like we did in the other ones, once I know the x value of my vertex, I can find the y value by plugging that in for x's in my equation and evaluating. Negative 1 minus 1, negative 1 plus 3. Negative 1 minus 1 is negative 2. Negative 1 plus 3 is positive 2. Negative 2 times 2 is -4. So our vertex is at -1, -4. Oops. Green. -1, -4. And now I'll also draw in that y-intercept and go ahead and graph. Oh, that's not very good, is it? Let me try that again. There's my graph. Our graph is opening up. Our domain, -infinity to infinity. And our range, we have y. It's opening up greater than or equal to. And the y value of our vertex is -4. So y is greater than or equal to -4. Number 2. So this negative on the outside flips our graph, which is an x-axis reflection. We have P and Q. Again, finding our x-intercepts or zeros, we take x plus 1 is equal to 0. X minus 5 is equal to 0. Solve for x. Minus 1 from both sides to get x alone. We have x is equal to -1. So that x-intercept is -1, 0. Add 5 to both sides. We have x is equal to 5, 5, 0. The y-intercept, remember we plug zeros in for x's. So we have -0 plus 1 times 0 minus 5. Do that math in your head or on the calculator. 1 times -5 is -5. And a -5 is positive. So our y-intercept is at 0, positive 5. Remember, we're going to start with plotting our x-intercept. So I have one here at x is -1 and over here at x is 5. We need to find the distance from -1 to positive 5. 1, 2, 3, 4, 5, 6. So from -1 to 5 is 6 steps or units. Half of 6 is 3. So the vertex is 3 steps from, I can try to spell that better here, -1 and 5. I'm going to erase this purple on here. So 1, 2, 3 steps from -1, I am at positive 2. I'm going to draw in my axis of symmetry there at positive 2. My axis of symmetry is x is equal to 2. And then we find the y value by plugging in 2 for x in our equation. So we have -2 plus 1 times 2 minus 5, and evaluating or finding the answer of that. And when we do that math, we have -3 times -3, which is positive 9. So our vertex is at 2, positive 9. So I'll plot that here. Now I'll plot that y-intercept, and that allows me then to make my graph as best I can here. Our domain, as always, -infinity to infinity. And our range, we have y. The graph is opening down, so less than or equal to, and the y value of our vertex is 9. All right, our last example for this evening, we're again taking a look. We have a 3. A 3 is our A value, and this is going to be a vertical stretch by 3. We have P and Q. So our x-intercepts are zeros. We have x minus 2 is equal to 0. X minus 6 is equal to 0. Add 2 to both sides. X is equal to 2. So that x-intercept is 2, 0. Add 6 to both sides. X is equal to 6. And that x-intercept is 6, 0. Our y-intercept, plug in 0 for the x's now. 0 minus 2, 0 minus 6, and evaluate that or find that answer. We end up with 3 times 12, which is 36. Ouch, that's a big one. Again, starting with plotting my x-intercepts, I'm at positive 2 and positive 6 on the x-axis. The distance from 2 to 6, 1, 2, 3, 4. So our distance is 4 steps. Half of 4 is 2. So we are 2 steps away from the 2 and the 6. So I'm going to take that off there. And if I go 2 steps from 2, then we are at x is 4. So the x value of our vertex is 4. Our axis of symmetry is x is equal to 4. Finding the y value, remember we plug 4 in for x in both spots. So we have 3 times 2 times negative 2, which is negative 12. So we're just going to estimate here where negative 12 is. And we'll put that about right here. I'm not going to plot that y-intercept at 36, so I'm just going to do my very best to draw this graph. Remember, we're trying super hard to make this not look like a V, and maybe do a bit better job than I did on my drawing. This direction is opening up. Our domain is negative infinity to infinity. And our range, we're opening up, so greater than or equal to negative 12. That's it for this chapter. Thanks so much for joining me. Have a great rest of your night.